Okay, let's talk about something you're doing right now without even thinking about it. Taking a breath. It feels like the simplest thing in the world, right? But the science behind just one single breath? Well, it's absolutely incredible.
So, just for a second, think about it. This simple act, moving air in and out, how many times do you think you do that in a single 24-hour period? Whatever number you have in your head, it's probably way, way higher.
That's right, over 20,000 times. Every single day, your body pulls off this amazing, life-sustaining feat. So today, we're going to break down exactly how it works.
Now, to really get this, we've got to start with the lingo. We all call it breathing, but in the world of science, there's a much more precise word for the actual physical movement of air.
And that word is ventilation. It's all about the mechanics, the physical process of getting gases into your lungs and back out again. So as we go through this, just remember that what we call breathing, science calls ventilation.
So how does this ventilation machine actually work? Well, there's a really common misconception about what's really going on inside our chests every time we breathe.
It just feels intuitive, doesn't it? It feels like we're actively pulling or sucking air into our bodies. But it turns out that's not what's happening at all. And this is the absolute key. We don't suck air in. The whole process is passive. It all comes down to simple physics and changes in air pressure. So how does that work? It's actually a super elegant two-step dance. First, a bunch of key muscles contract, which makes your chest cavity bigger. When that space gets bigger, the pressure inside your lungs drops. And nature doesn't like an imbalance. So to equalize that pressure difference, air from the outside just flows in, all on its own. No sucking required.
And what's so cool is how perfectly symmetrical it is. When you inhale, your diaphragm and rib muscles contract. This increases the volume in your chest, drops the pressure, and air flows in. And to exhale, you just do the opposite. Those muscles relax, the volume shrinks, the pressure goes up, and air just flows right back out. It's a simple, brilliant, and incredibly efficient system.
Okay, so now we know how the air gets in. But where does it actually go? Let's follow its path, from the outside world deep into the center of your lungs.
The journey starts down your trachea, your windpipe. From there, it splits into two big branches called the bronchi, one for each lung. But it doesn't stop there. These tubes split again and again and again into thousands of smaller and smaller tubes called bronchioles. It's like a giant branching tree inside your chest, all designed to carry air to its final destination.
And that final destination, at the very end of those tiny branches, that's where the whole point of breathing actually happens. We're talking about the microscopic level now, where your body grabs the oxygen it desperately needs and dumps the carbon dioxide it doesn't.
These are the alveoli. These little guys are the real MVPs of your respiratory system. That whole complex tree of tubes we just talked about, its only job is to get air to these tiny, incredible structures.
And how many of them do we have? Well, in the average adult, there are somewhere around 600 million alveoli crammed into your lungs. That number is just staggering. And it's for one very important reason, to create a massive amount of surface area. So, let's play a game. If you could take all 600 million of those tiny sacs and lay them out perfectly flat, side by side, how much space do you think they'd cover?
Seriously, a tennis court. You have a surface area the size of a tennis court folded up inside your chest. It's almost unbelievable. And all of that space is dedicated to one single task, moving oxygen into your blood and carbon dioxide out as fast and as efficiently as possible.
This entire amazing system we've just walked through is incredibly resilient, but it's not invincible. So how can we take care of it? It turns out our daily choices have a huge impact on how well this incredible gas exchange machine can do its job.
This table sums it up perfectly. On the one hand, something like exercise strengthens the very muscles that power ventilation, making the whole process more efficient. But on the other hand, a condition like asthma causes those airways to swell up, making it way harder for air to move in and out. And smoking? Well, that's a double whammy. It damages the airways and it literally destroys the walls of the alveoli, permanently shrinking that tennis court-sized surface area you rely on. So, let's just quickly bring it all together. The big takeaways? First, breathing isn't suction. It's a passive process all driven by pressure changes. Second, the real work happens across 600 million tiny alveoli. Third, all those little sacs give you a massive surface area for gas exchange, as big as a tennis court. And finally, and maybe most importantly, the choices we make every day directly impact how well this amazing system works.
Every day, this complex, beautiful process happens over and over again, more than 20,000 times, without you ever giving it a single conscious thought. So knowing what you know now about how it all works, the question is, what are you going to do to help it perform at its best?